All right, cryptocurrency. So who here has heard of? Actually, this might be better to do because if you guys are responding in the chat, it might be better to do in the with the chat. So let me try to see if I can pop the screen open. All right, we'll just do like this. Who here has heard of blockchain or cryptocurrencies before? I guess it's gonna be hard to if they can't really speak. Okay, yep. Okay, cool, cool. All right. Let me see if we can actually make this a different tab, and then make it smaller. That way, I can actually see the chat while I know people might want to. Okay, cool. This is perfect. All right. So great. People have heard of blockchain and cryptocurrency tech before. That's good. So yeah, so we'll be discussing essentially the essence of blockchain technologies, cryptocurrencies, what they are, how they work, what you can build on top of it, um, and just going into that. So um, with the second slide, so agenda. First, we'll have a history and overview of popular cryptocurrencies. We'll have a review of common development practices. We'll look into some difficulties of learning smart contract platforms. Um, we'll look ahead to several open problems, and then we'll look ahead and discuss some open problems. So, what is a cryptocurrency? A cryptocurrency is a digital asset that secures the public-private key cryptography. And by the way, actually, I didn't introduce myself. So, my name is Archie Chaudhary. I'm the co-founder at Atomite Labs, which is we're building a new layer one blockchain development platform, so like Ethereum, like Bitcoin, and yes, I'm a mentor for the Curious Learning session. So we jump right in. But yeah, so what is a cryptocurrency? A cryptocurrency is a digital asset that's secured to public-private key cryptography. So what does that mean? It means it's essentially an asset that's entirely on the internet. So just like you exchange dollars or Canadian dollars or um, other forms of cash, U.S. dollars, etc. You can even do that on the internet. A cryptocurrency is a digital asset that's entirely free from any sort of central party. In most cases, we will discuss some edge cases, and as you see in the second sentence here. But in most cases, they're decentralized, meaning that minting and record keeping of the asset is controlled by a sparse network of validators. So, this is from the presentation here. In the chat, feel free to say, so how, and for like the Canadian dollar, how do you think new coins are generated or new dollars are generated? Feel free to unmute yourself or say to the chat. How is new currency added to the ecosystem? Yeah, I mean for typical, I'm saying for cryptocurrency, yes, but for your typical like, I guess fiat, we like to call them fiat currency, but like Canadian dollars or U.S. dollars, how are they generated? Yeah, yeah, that's perfect. And so yeah, exactly. So a federal mint, at least in the United States, I'm from the United States, but I guess in Canada, some sort of centralized mint um, essentially creates. Yeah, you were Leo. You were getting ahead of yourself. Um, well, we will discuss mining later. Don't worry. But some sort of centralized mint essentially manages to you know introduce new currency to the network. So we call that inflation. If anyone saw the news, people are just going crazy about how inflation is rampant, how it's going to kill the economy. Doom and gloom. Oh no. But essentially, the main point is the government or some central party or authority, when they feel that hey, we need to inject more cash or make more dollars for the ecosystem for the government. Exactly, Jeffrey. Yeah, lots of inflation. Um, um, they'll do that. So the reason there's a lot of inflation right now is because because of the pandemic over the past couple of years, because of just the general economy. There's been a need for a lot of support in the in for the various countries for the economy. And for that reason, a central mint introduces inflation, whether that's maybe to fund the military. And there's a lot of reasons. So, this is not a government or economics presentation. So I'm not going to get too deep into that. But essentially, what you need to know is, there is some sort of central government that can arbitrarily introduce, new units or new units of this currency into the supply without really um, any sort of prediction. So going back to the presentation here, not my messages. um, so yes, a cryptocurrency is a digital asset that's secured to publicly. Okay, so when we say now the record keeping and minting of the asset is controlled by sparse network validators, um, what that means is instead of having to go through a mint that controls the monetary policy of this cryptocurrency, you have to. It's controlled by essentially in a way and everyone, not everyone, but essentially anyone who is, I guess, cryptographically or mathematically validated to do so. And anyone can be this a validator. So going to the example of Bitcoin, and that's actually going back to Leo's point. Going to the example of Bitcoin, there's a process called mining where essentially anyone can, as long as they manage to prove cryptographically that they've contributed some amount of computing power to the network by solving a computationally difficult problem, they managed to add new core. They managed to act as a record keeper for the transactions, and the, they get rewarded with new tokens. So Bitcoin has a hard cap. So does anyone know what that hard cap is? Feel free to say in the chat. Anyone know what the hard cap for Bitcoin is? The maximum amount of Bitcoin that there'll ever be in the supply, in the monetary supply. Well, it's 21 million. So the maximum amount of Bitcoin that there'll ever be in the actually I'll stop sharing for a bit. In the monetary supply or in the overall supply is 21 million. So there'll never be more than 21 million total Bitcoins in the ecosystem. Whistles. Um, so you can compare this with something like US dollars, Canadian dollars, or literally any currency, any physical or fiat currency in the world. There is no hard cap. I mean, as we were talking about earlier with inflation, the government can introduce new units of currency at any time. With Bitcoin, since it's like this programmable money that's embedded in software, there is a hard cap that, okay, there'll never be more than 21 million Bitcoin in the ecosystem. So let me share my screen again. We're gonna go and take a look at. I'm trying to find the. Oh, there it is. Let me go to the. So more here. This link to pull up. There we go. All right. So getting a little bit into Bitcoin mining. I'm gonna be this presentation is posted online. So if you want to take a look at these resources later, feel free to do so. So mining adds new blocks to the blockchain. We're going to get into these concepts later. That's not really important. But what is important is it makes transactions hard to modify. So you can think of the blockchain as a record of all transactions, and you can think of mining as the process in which these transactions are added to this database. So, most simple example: if we started a cryptocurrency, I'm gonna stop sharing again. Just between the 15 people in this room right now, if we started a cryptocurrency, um, there will be some sort of ledger or database keeping track of who sent coins where. Um, you know, if I sent one curious coin to Leo, uh, how can everyone else know that I wasn't just making it out of thin air and I actually had possession of the coin or I hadn't spent it before? There needs to be a database, and to maintain a database, we'll say that Tommy has yeah, exactly. Tommy has or Mary, Tommy and Mary both have the ability to propose new coins to the network, or they're in charge because they have been either they, and this is actually applicable in some cases. They're either trusted by everyone or they have the most computational power, so they're picked by the algorithm, and they're the ones in charge of proposing and keeping track of this database. And say Katrina or Katarina, let me see, let me know if I'm saying this correctly, gets more computing power, she can replace Mary, or she can replace Tommy. And essentially, this is an ongoing ecosystem in which everyone's competing to get the most computing power, and um, they're able to get the most they're able to get the most of coins out of the network. So okay, cool. So we will go back into sharing again. So this is really, and we'll discuss this later as well. So today, mining is often done in pools. So I showed you guys this. So this is sort of the hardware that you need to actually mine today. So you can't just download the Bitcoin mining client on your laptop, or in my case on my MacBook, and start mining. The hardware you need is actually very intensive. So back in the day when Bitcoin was first created, it was actually quite easy to mine blocks. But now, because there's so many people using the network, and because network, the amount of coin, the amount of users, and the amount of transactions occurring per second have really increased. Now you have to have a lot of computing power to actually be able to run a node in mine. So moving on, now finally, some background. So who invented this? Why should we use it? And what's the significance here? So I'm actually present this because this is the important part. Bitcoin was invented by this anonymous person named Satoshi Nakamoto. So now no one knows who he really is, and to this day, no one knows who he is, or they or she. We don't know who they were. Um, and what the quote from here is, "I've been working on a new electronic cash system that's fully peer-to-peer with no trusted third party." Um, and the cool thing with Satoshi's comment there was that because that he was working on it's that's the simplest definition of Bitcoin. So I know a lot of people think cryptocurrencies and blockchain are this sort of complex technology, but essentially the basic you know basic definition is it's an electronic cash system that's peer to peer, meaning there is no there, I don't have to go to the bank, I don't have to go to the government to send money or get money. um, it's fully peer to peer, and it's only between the actual users, and there's no third party that I have to go through. And Bitcoin's motivation was centered around this group called the cypherpunks, which was comprised of a bunch of individuals who believe in using cryptographic technologies for privacy. And we'll discuss a couple of their works and their cypherpunks through the first guided reading session, which is actually coming up. So, um, who let's actually, before we get into that, who here has heard of that group, the cypherpunks? Yeah, in the chat, if you want to put that in there. Completely okay if you haven't, because in high school I did not know who they were. Actually, I think I read a book about Bitcoin. That's when I figured out who they were. So yeah, so the cypherpunks were essentially this group of cryptographers. Oh, vaguely. Cool. Yeah. Cool. Um, yeah, the cypherpunks are essentially this group of just privacy-loving individuals who wanted to use cryptography, who believed in the ability of technology to fuel privacy-based, to fuel complete privacy. And you know, one of the and often people said, oh, this is sort of anarchy, or it's going to be used for criminal activity, which Bitcoin was, and we'll discuss that a little bit as well. Um, but the key thing there was that a lot of it was actually centered more around making having some sort of freedom for individuals to function and operate in society without having to place trust in any sort of institutions. So let's actually, on that note, I'm going to put the link in the chat in case I'll for the guided reading. Give me a second here. So you got a link. I'll be sharing my screen as well because I don't expect to read the entire paper because we don't have time. But just we'll be highlighting some of the important points. So I hope let's get into how transactions actually work. So what happens when you send one Bitcoin to someone else? Or actually going back to our example of Curious Coin, what happens when we send one Curious Coin, when Leo sends one Curious Coin to Ryan, right? Essentially what happens is that transaction gets sent to this, it gets sent to, if it's correctly formed, it gets sent to this, um, I guess, processing pool, where essentially the peer-to-peer network waits to process it, and then um, that the miner in this case, or whoever is selected to validate transactions, actually collects it into a block and uses cryptography to hash it and add it to the blockchain. We won't get into the actual cryptography functions unless you're interested. Let me know if you're interested. But I do think there's actually a workshop on cryptography, so I'm not gonna get really deep into cryptography or the cryptography part of cryptocurrencies, just the very basics. So um, you can think of the cryptography as essentially being essentially you think of cryptography like the cryptography used in Bitcoin. Essentially, it's a way to compress information down while ensuring that it's correct. So where if you have like hundreds of transactions, each transaction has all of this information, like who sent it, who received it, etc., the amount, the time. You want to compress that down so that it's easily stored and you don't get immense bloat. So that is why we use hashing functions. And there's multiple definitions for hashing functions. You have trapdoor functions, um, one-way functions. They're all the same thing. Essentially, it's the most basic definition that I can give is it takes all of this information and then creates a byte hash or a byte code out of it. And in order to verify that the hash is correct, there's a property of hash functions called collision resistance, which essentially means that if I take two different messages, if I, for example, take the Archie and I take Mary's name, Mary, and I hash them to the same hashing function, it will always be different. There's never going to be a period of time in which two different inputs lead to the same output. So it's one way, and one way meaning you can't take a byte size thing and go back and get the plain text or get the original sentence or word. So that essentially means that we compress all this information down, and then the miners and validators put this information and connect it in blocks. So hence the term blockchain. So and that's just in the video. Cool. Yeah. So hence the term blockchain, which is essentially the idea of you're gathering all these transactions, hashing them, and then connecting them together for reference purposes, right? So really, and with Bitcoin, this makes a little more sense. But even with later blockchains like Ethereum, as we'll discuss, it still applies. You essentially want to track where each coin is going. So if I'm going back to the oh, so this is actually perfect. Yeah, so you want to be able to track where each coin is going. So if I sent one coin to Mary, and then Mary sent one coin to Leo, the same coin, um, that this timestamp chain serves as a record of where that coin was. So you want to show that, hey, Mary didn't just come up with the coin on her own and she just broadcasted something she didn't have. Oh, cool. She actually got that coin from Archie. So you can see that in this history. And then talking about mining, because I know Leo was interested in that, mining occurs to something called proof of work in Bitcoin. We'll discuss some alternative ways later. But in Bitcoin, it occurs to something called proof of work, which essentially means that, again, as I talked about before, you are selected because you can compute X amount of computing power. And in the white paper, you can see um, the proof of work is essentially one CPU, one vote. So when you have this distributed ecosystem, you want to be able to say, okay, there has to be some measure of deciding which transactions are actually valid. In Bitcoin, you decide who gets to propose the next set of transactions by seeing who has um, the most computing power. And because of, and getting back to the idea of all of this being committed using cryptography and as a time, essentially a timestamp chain, each block has a certain amount of computing power, dedicated to it. And as that increases, and as Satoshi says right here, as later blocks are changed after it, the work to change the block would include redoing all the blocks after it. So if someone who just wants to interrupt Curious Coin, um, and they wanted to make it invalid, um, they would, and going back to the example of me sending a coin to Mary sending a coin to Leo, they would have to go back, and if they wanted to say, oh, they wanted to make it so that I never had the coin in the first place, they will need to reverse all the transactions that occurred after. So they will need to reverse the transaction that Leo sent, that Mary sent to Leo. They'll need to reverse the transaction that I sent to Mary, and then they can look at mine. So that sort of added cryptographic measure ensures security in the long run. And that's why, really, when you look at cryptocurrencies, Bitcoin is known as one of the most secure, or the most secure digital currency. So, any questions? But I know that was a lot. So, I'll pause for questions. Feel free to type them in the chat. What if they did reverse it successfully? Yes, that's a great question. Yeah, I mean, essentially, and in the Bitcoin white paper, Satoshi talks about this. But if someone, essentially, what you would need to reverse it is you will need to have, and this is something that's called a 51% attack. You would need to have 51% of all the computing power in the entirety of the ecosystem. So and the small example of Curious Coin, um, say since you asked the question, right, say you wanted to reverse and you wanted to essentially break the chain, and you wanted to, because if you manage to reverse, then you'll be able to decide which coins go where, so you could give all the coins to yourself. um, but so in that sense, what you would need to do is you would need to have more computing power than everyone else combined, right? So you would need to have 51% of all the computing power, which means all of us will have 50 and you'll have 51. And if you have that, then you can essentially, you have the ability to essentially control where coins are going. But let me actually share my screen again. There's actually an economic incentive for you to not do that, even if you have all of it. Let's see here. Yeah, so incentive, right? So so if a greedy attacker is able to assemble more CPU power than all the honest nodes, he would have to choose it between using it to defraud people by stealing back his payments. And that's one of the first. The first example is that the best example of what you would do if you had that power would be you would send coins to people, they would do some service for you, and then or they'll give you something, and then you just use your computing power to take it back. Or you can just be the miner and get all the rewards anyways. And the economic argument here is it's better for you to play by the rules and just mine and keep keep adding blocks to the blockchain, because now that you have the most computing power, you'll be the one who can propose and add new blocks to the ecosystem. And it's just it makes sense for you to play by the rules and just do it honestly, rather than spending so much money on getting the computing power and then reversing it and essentially undermining the trust that people have in the ecosystem, because then you won't get rich. Um, and to quote the Dark Knight Batman, there are people who want to watch the world burn, but in most cases they don't have 100 billion. I think it's actually almost $1 trillion now that you would need to actually uh, have enough computing power to overturn the Bitcoin ecosystem. So, does that answer your question, Leo? Or not, Leo? Ray? Cool. Anyone else have any other questions on the basics of what a blockchain is, um, and how cryptocurrency transactions are processed? Five, four, three, two, one. All right, cool. Then I guess we can move on. You guys are quiet. Share the screen again. Yep. So now let's get into Ethereum. So who here has heard of Ethereum before? In the chat, feel free to reply. Yes. All right. Cool. One person. All right. Great. All right. Yep. Okay. Leo. Great. Yeah. So Ethereum allowed people to build smart contracts. So what does that mean? Let's get into it. They allow people to build decentralized applications, and this gets into the actual learning / hackathon part of the presentation. Well, we're not actually going to do any programming today, but the actual like computer science programming aspect of it. Ethereum and other smart contract platforms allow for the development of decentralized applications and smart contracts on the blockchain. So first, let's actually figure out what smart contracts actually are. And before we get to that, I'm going to offer my simplified explanation. So smart contracts are essentially trustless agreements on the blockchain, or not on blockchain, they're trustless agreements on the internet. So an example would be, say, I wanted to sell Edward a house, and Edward would, typically what we'd have to do is if I wanted to sell Edward the house, we would have to go through a retailer to connect us a notary to actually notarize the documents, maybe a financer or a lawyer to actually figure out how we're going to pay for this stuff, and definitely a bank. If it was done through smart contracts, it would be on the internet, and I could send the date to my house over the internet automatically when Edward sent me the money. It wouldn't even be me sending it; it would be a program that we both trust that would send it. So the reason it's trustless is because Edward doesn't have to trust me. I don't have to trust him. All we have to really look at is, okay, if this code executes properly, then it's ensured that I will have the money I want and Edward will have the deed for the house. An example is like with Curious Coin, if I wanted to pay Leo um, to for to run the next set of Curious Hackathons or Learnathons, right? I could make a time lock that would wait till, or a time contract that would wait till next year, July, and it would see if Leo actually completed his task by, maybe you'll check, maybe you'll use a Zoom API to see if Leo actually logged into Zoom and actually did his tasks for Curious. And then if he did so, then he would get paid from my account automatically. So can anyone think of a non-internet / blockchain application that currently is a smart contract that fits this definition of a trustless thing where you don't have to trust people? Something in the world that we use quite often. Yeah, in the chat, feel free to put that in there. This is something we use, right? You see it in, as an example, as a hint, you see it in airports, malls, stores, all over the place. Universities, schools. It's something that's quite common. Well, it's a vending machine. So for a vending machine, instead of paying cash to um, a cashier and getting your soda, you can put cash into a machine that automatically gives you soda once it sees that you put in the correct amount of cash. Right. Definitely, there is some trust that you have to actually make the machine correctly, but that's the most basic example of a smart contract. And let's actually get into. Let me share my screen again, and we'll get into the meat of stuff here. Okay, cool. So smart contracts. This is a great example. So smart contracts were invented by Nick Saslow. So he was also part of this group called cyberpunks. And he, again, using internet technologies and cryptography for trustless and private. So right here, see the vending machine is a contract with bearer. Anybody with coins can participate in exchange with the vendor. The lockbox and the security mechanism protect the stored coins and contents from attackers sufficiently to allow profitable deployment of vending machines in a wide variety of areas. And so smart contracts in the most base, in the current sense, go beyond vending machines in that they embed contracts digitally everywhere. So, this for example, one is considered a hypothetical digital security system for automobiles. You can transfer the deed of the car to or the operation, the key to be able to use the car to different people, and as long as they don't have that, they won't be able to use they won't be able to use the car, and then there could be some other protocols where if a if you borrowed money to buy the car and you fail to make payments, then the car keys will be returned to the bank and they'll repossess your car. So this is like the most basic version of what a smart contract was, and this was in 1999 or 1997 actually. So actually getting into, and actually let's see how this is here. Now let's get into the Ethereum white paper, which is actually written by a fellow Canadian, well not a fellow, by a Canadian, Vitalik Buterin, where he thought, okay, why don't we combine smart contracts and why don't we just put them on the blockchain? So why don't we just record any transactions you do on the blockchain using, or why don't we record smart contracts as transactions on the blockchain? So without getting into the mathematics of it, because I know you guys are not interested in that. It's a little bit down. Okay, cool. This is the most basic version of a smart contract, right? So if we wanted to create Curious Coin in Ethereum, we could do so in well, this language no longer exists, and we'll talk about this later. But essentially, all Curious Coin will need to have would need to have some method of being able to send from one person to another. So if you look at this basic Pythonic code, there is a sending function that sends it from the main account to someone else, and it also has the value. And then if it checks if the storage of the message sender is greater than equal to the value, then the sender loses that, and then the recipient gains it. And if it's not, it just doesn't send. So that's the most basic version of a token system, which is one of the most popular use cases of smart contracts. So to talk about how Ethereum actually succeeded is, I'm going to stop sharing again. So who here knows what Turing completeness is? This is a more general programming term. Turing completeness. Put it in the chat if you know what it is. Leo, what is it? What is Turing completeness? I'll just explain it. Turing completeness is essentially yes, okay, I believe to run a Turing machine. Yes, that is correct. A Turing machine is in a more simpler sense, instead of getting into what a Turing machine is and whatnot. It's essentially you can essentially, without thinking about the practicality, the physical constraints of the resources you have, you can run a program indefinitely, and it can theoretically execute an infinite amount of computation. So basically, if you want to determine whether the programming language is Turing complete, the only question you need to ask is, can I do loops? Because theoretically, on any programming language, as long as you have some sort of infinite computer, you can run a for loop that continues executing for all of time and space and eternity, right? So that's what a Turing machine is, or Turing completeness is. And Vitalik um, essentially said, okay, what if we made programs on the blockchain that were Turing complete, that could execute for all space and time? And that was embedded in smart contracts. So resharing my screen here. I might have closed it here. Yeah, I'll close it here. Give me a second. But essentially what it allowed him to do was, you can now create smart contracts that live on the blockchain and they're Turing complete, which means that as long as they have the resources they need to be able to run, they'll continue to exist for all till the end of time, or till the blockchain itself dies out. So now I can actually pull up my thing again. So I have to go down again, which sucks. All right. So trustless smart contracts recorded as programs on the distributed ledger are combined with front-end technologies to create functional DApps. So you can think about it as, you have all of this code that dictates where transactions go, where curious coin goes. Now that that's self-sufficient, there might be various, sort of trusting Mary to give me a curious coin. I can do some action. Maybe I can participate in a curious ecosystem, and I'll automatically get coins based on some validation. And this is combined with front-end technologies to create functional DApps. So DApps are essentially, you can think of them as a full stack application. So smart contracts essentially for blockchain and cryptocurrency, they're the backend. You can think about it that way. That's not entirely correct, but it's a good abstraction. And then front end is just your typical, HTML, CSS, React, JavaScript, et cetera, to actually create, functional dApps. So one good example of a decentralized application is Gitcoin, Gitcoin Passport specifically. So with Gitcoin Passport, what you can do is you can create an identity record about various credentials about you. So actually getting into what Gitcoin actually is. Gitcoin is this grant, um, a grant giving platform, through a grant funding platform that gives open source developers funding so that they can pursue their projects. And they use a platform called quadratic voting, or quadratic funding, where you are able to put your proposal online and then people vote for it, and whoever essentially gets the most votes, that gets the tokens. And one of the problems with this, obviously, as anyone will say, is was to stop someone, because it's all on the internet, from creating 50 million different identities and all voting for their own project because they want to get all the funds. So this is sort of their solution, is now you can connect all of these different, your Google profile, your Facebook profile, your Twitter, to some sort of identity, and that will be your identity on the internet. And I don't actually have my wallet activated, but typically the way you interact with the DApp is you connect your cryptocurrency wallet, and then you're able to actually interact with the DApp and interact with the underlying logic. And based on how the DApp works, you'll get some tokens out of it. Back here. And then another cool one is Proof of Humanity. Feel free to go to that link later. For the interest of time, I'll continue moving on here. So Ethereum was good for a very base, it was sort of the first proof of concept for, or the first, not proof of concept, first blockchain that actually accomplished putting smart contracts and putting actual programmability on the blockchain, right? So Bitcoin, it works great as a decentralized currency. Arguably, it's still the best decentralized currency and asset in the world, but it obviously has a lot of problems. And this is a great time to discuss what are some problems that you've maybe heard of on the news with Bitcoin, or just reading around or doing self research, and put that in the chat. What are some problems you've heard of with Bitcoin? 5, 4, 3, 2. I'll sort of get into it. The Actually, I might actually start calling on people just to encourage participation. I'll do that. I'll do that for the next slide. But essentially, what you have with proof of stake, proof of work, with Bitcoin, you really have a a great digital currency that can't do much else. And there's been some work with the Bitcoin ecosystem. Bitcoin developers have been making, you know, they've built the Lightning Network, which now allows you to do some, do some more scalable stuff. It enables you to, act. And we won't get into layer two um, just yet. We might do so at the end if we have time. But it lets you abstract a little bit more. You can do some more stuff with Bitcoin script, but at a base layer, it's still limited. Ethereum, managed to build on that by building, the base layer for what programmability applications on the blockchain might look like. They're actually, you know, I only looked at Gitcoin and I only looked at Gitcoin and maybe I linked proof of humanity in there, but there's so much more. I mean, those are not even the most popular ones. Those are ones I particularly like because of what they're trying to achieve. But there's ones like Uniswap, MetaMask, not MetaMask, but Uniswap and OpenSea, and a whole lot of different platforms that essentially do the same thing. And one of the most popular use case for for that programmability. Does anyone know what the most popular use case is right now? I'm gonna call on someone. Leo, what is the, just type in the chat? What is the most popular use case for cryptocurrency for Ethereum and blockchain programmability right now? Do you think? Or Ray or anyone, but calling on someone specifically. Feel free to put it in the chat. What is the most popular use case currently? Cryptocurrencies. Let me actually. Yep, absolutely. Yep. So NFTs are the most popular use cases of cryptocurrency. So right now we've the only sort of programmability that we have explored so far, in majority, is financial applications or the transfer of assets. And we'll get into that a little bit later, why those limitations exist. But um, you know, that's all we've sort of gotten into. So, you know, platforms that came after Ethereum, like Solana, Algorand, Cardano, um, they scaled these base layer. So we call any blockchain that like Bitcoin or Ethereum that it has a cryptocurrency and it settles transactions through some sort of chain, a layer one chain, and and these new platforms provide the means to support more transactions per second at a much lower rate. And they did so by using something we like to call a proof of stake protocol. So, what is a proof of stake versus proof of work? The most basic explanation is with a proof of work, you're essentially using computing power to, we talked about this earlier, like with Curious Coin, um, you know, if Mary and Leo and Jeffrey are selected to essentially validate the network because they have the most computing power. However, with something like proof of stake, they're going to be selected randomly, but weighted by the amount of coins they have. So the reason that's a little bit better is because transactions are not going to take as long to process because you don't have to solve this massive cryptographic problem to prove how much computing power you've dedicated. And you, I mean, that's really the main thing. And since you don't know how to do it, transactions are a lot faster. And it's not that inefficient for, and I'm sure people have heard of this in the news, um, it's not that inefficient for the environment. So with proof of stake, since you're doing that, you're using coins. That and there's several efficiencies, different consensus mechanisms. So consensus mechanisms essentially like how are you coming to a decision based on the based on where coins are and where coins are going. So in our curious coin part B1 per se, we came to consensus by the same way Bitcoin does by looking at who has the most computing power and selecting them. Something like Solana or Algorand, now Curious Coin V2, what we're discussing right now, we use who has the most coins in the network and have them actually propose blocks. So Solana can actually process over 50,000 transactions per second. And this is actually, I'm going to put this link in here. Feel free to try this out while we're. And I'm going to share my screen actually. So this is pretty cool. So this is something called Break Solana. So it's a game that you can play with the Solana blockchain. And I'm gonna do it right now. I'm gonna select my account, and see how it works. I'm gonna play, and essentially what I'm gonna do is I'm gonna try sending as many transactions as I can in a span of 15 seconds, and then we're gonna see if that actually manages to crash Solana's network. So I'm gonna send as many transactions as I can. And cool. So I sent 87 transactions in 15 seconds, and that only took up 0.012% of Solana's capacity. If this was on Ethereum or Bitcoin, as you can see right here, Bitcoin wouldn't have been able to support this in its current state. And Ethereum, this would have taken up 40% of Ethereum's capacity, just me sending 89 transactions like a madman. So, you might be thinking, okay, what crazy person is actually going to send 89 transactions in the span of 15 seconds? Yeah, so if you're just a regular person using a currency, you won't. But if you're an application that lives on the blockchain, as we talked about earlier, and you are sending transactions, maybe you're a game and you're trying to you're recording every move a player makes as a transaction, or maybe you're a game and you're using an inbuilt currency in every currency, like maybe it's World of Warcraft on the blockchain, and every time you buy something, that's recorded as a transaction on the blockchain. You only just support a whole lot of transactions if you want to keep that game going, and that game is just one of many games or many applications within the ecosystem. You'll need to support a whole lot of transactions. So that's why Solana is being used a lot for making games, making financial applications that require a lot of transactions. So any sort of financial protocol where you need to process a lot of different individuals and a lot of different transactions, that's going to need a very high transaction throughput. So sharing my screen again, and Ethereum up until now, Ethereum's actually trying to do they're trying to do an upgrade. So since and then with their Ethereum 2.0 protocol, but they're still sort of lagging behind on that, and it's still a while until they accomplish it. That's something they've been working on essentially for the past 4 or 5 years. But moving on, we were on. Oops, not on this slide. Yeah, so Solana and all these different platforms sought to focus on one specific thing. Solana is a great example because they have that game. I wanted to display it, where they're really trying to get as many transactions per second so that they can support these complex applications that we talked about. And on that note, does anyone have any questions on smart contracts, layer, third generation blockchains, etc.? Feel free to put it in the chat if you have any questions on proof of stake. Why is that better than proof of work? Why is proof of work so not the best for more complex applications? What are maybe some of the pitfalls of proof of stake? I didn't really discuss that because I thought maybe you guys would want to hear, but if you do, just let me know in the chat right now. Yeah, I mean, it shouldn't really be the main idea with the main problem with that you see with a lot of proof of stake protocols is you it essentially creates like this sort of security hazard where someone can, if they have a lot of coins, or with the since everything's not validated due to this immense amount of computing power being dedicated, there may be some leakholes. And even Solana has experienced downtimes in the past because they're still sort of ironing through potential leaks and potential exploits in their blockchain. But if people don't have any questions, or if it was unfortunately beyond everyone, which I hope it wasn't, um, we will continue moving on. So I would really like to think of, I think the best, and this sort of fits into the theme, the best sort of analogy to blockchains, and this is me as a developer, the best analogy I have for blockchains are programming languages, right? So this is the one thing I did not mention. You can think of Bitcoin as being this, assembly Bitcoin script, which is the programming language that people use to build stuff on Bitcoin. You can think of it as being assembly. It's quite low level. It's not Turing complete. You can't do. Sorry, that's my dog in the background. You can't do much with it. With something like Ethereum, it's like C, C sharp. It's a little more low level. There are some things you can do with it, but not a whole lot. And then with something like um, um, Solana or Algorand, you can do a little more with it. So moving on here. Oh, sorry, I got disconnected for a second there. So how does this actually work under? Yeah, the analogy makes some sense. Yeah, exactly. So yeah, you could yeah, exactly. So you can think of the language that Ethereum uses as that is Solidity as sort of the most um, basic um, yeah, sort of the most fundamental way to use something like this. But yeah, so how does it actually work? Um, and we'll talk about the specific programming languages later, Ray. But yeah, that's the analogy I like to use the most. Some other people might want to say it's an operating system, but typically, because technically you're building applications, so it's like operating system like Microsoft or Linux or Ubuntu or Mac OS, because you're building applications on it. But I always like to think of it as programming languages because as developers or as users, that's ultimately sort of the different layers of abstraction that you're dealing with. So how does it actually work? So when you send a transaction from your public address, aka your public key, and you sign it with your private key, and this was probably covered in the cryptography presentation, which if you guys went to, hopefully you guys went to. When you send a transaction from your public address, you send it to someone else's public address. This is broadcasted directly to the underlying peer-to-peer network, and the node then processes it. So because the transactions broadcast, so what's a peer-to-peer network? You guys are probably asking, what's a peer-to-peer network? A peer-to-peer network is essentially the way decentralization is achieved. So going back to the idea of curious coin, the peer-to-peer network will be between all of us. We'll all be connected with each other, and we'll be able to see, we'll get direct updates on when new transactions occur. And because that's the case, because that's the case, new transactions will be able to be added to the blockchain, to the consensus process, and then it'll be processed to all nodes. Some nodes might reject it, creating a fork, and then you have the distributed ledger. So let's walk through each of these processes and see what they mean. So first you have, so the peer-to-peer network, going back to the idea of curious coin, you have between all of our the underlying peer-to-peer network, you have it between all of us, and then with the here, and then this transaction is added to the blockchain, to the consensus process, and then it's then processed to all the nodes to make it legitimate. Now, some nodes might reject this, creating a fork. What that means is, within the curious coin ecosystem, some of us might say, oh, yeah, we don't agree with the fact that Archie has 100 coins. We might want to make something else. If that's the case, then there's a fork that's created. A fork is essentially a different history of the blockchain. So you can think of it as with Bitcoin, if you have this consistent, one layer history, where it's going from A to B, with a fork of Bitcoin will maybe have a different history where the coins from A went to C. So with Curious Coin, maybe if someone says, oh yeah, I don't think Archie should have 200 coins, or maybe he didn't have enough coins to send to Edward, they would create a fork of it, and they'll be able to essentially say, have a different history where Archie maybe doesn't have 200 coins to give to Leo. So that's what a fork is. So moving on here, does anyone have any questions about the essential ideas there, about what a fork is, how transactions are processed, what a peer-to-peer network is? Feel free to ask in the chat. Feel free to ask questions. It doesn't look like anyone has any questions, so we'll move on. Cool. So moving on. So what are some current problems that we see in this space? First is storage. So as we talked about earlier, even though stuff is hashed, you still have to, it still gets to be a lot when there's millions and millions of transactions over a long period of time. And these transactions, so a great example of this is Bitcoin, which now I think is several terabytes to actually run a full node and participate in a peer-to-peer network. You need to have enough storage on your computer to be able to process this. And most people don't have that. So you often have to rely on someone else who's running a full node to actually be able to send transactions and to interact with applications. And the same problems with Ethereum. So currently, and I'm going to refer to, for example, Infura, currently one of the most popular platforms for running Ethereum nodes is Infura. So if you and MetaMask is a direct part of Infura. If you're running if you say I wanted to like that Gitcoin passport example I showed earlier, if I wanted to interact with it or make a new passport, I have to register my wallet and I have to use my wallet to connect directly with the blockchain. And I need to do that through a full node because as this showed, this the transaction must be broadcasted to the underlying peer-to-peer network, and that can't happen unless I'm connected to a full node. So I have to rely on something like Infura or MetaMask to actually do this. Problem is that can be subject to censorship or worse, go completely offline. So Infura, for example, recently just announced that they can no longer um, broadcast in, or they can no longer be used in Iraq, Iran, and some other countries. So people in those countries, who most of them probably don't have the technological capabilities to run a full node, download the entire history of the blockchain, are now can't use this technology. So when talking about decentralization and trust or the lack of trust, that's this system should theoretically be able to enable. We don't really have that with current systems. And then going to consensus. So proof of work mining is inefficient for application development. We already sort of talked about this. If you have this massive application that needs to exchange millions and millions of bytes of data per second, using proof of work mining is really not the best for that. And it causes significant damage to the environment. Debatable, but there's definitely the argument to be made that using proof of work mining at a scale, even if we manage to scale it, would be detrimental to the environment. It works great for a decentralized currency for a single use case, but scaling it might cause significant damage. Proof of stake protocols are insecure and susceptible to DOS attacks or centralization. So, and I'm not going to skip this slide because it's not really important. Getting into problems with decentralized application development. So the main problem with that is current smart contract platforms are too hard to learn, lack basic security features, and they're clunky and inefficient. So I'm actually going to, this slide is not really that important. Yeah, exactly. Well, even if they don't need to be any question is a good question. Right. Any question is a good question. I'm actually, we can even leave the last sort of 13 minutes for open discussion if that's something that people are interested in, or 17 minutes. Because I think a lot of this, it's important to have open discussions on, especially the concepts surrounding privacy. But if that's interest, if that is of interest, just let me know. Meanwhile, I will continue to go through the slides here. And I'll actually skip around a couple because I do know in the interest of time we might not want to get to everything. Yeah, so we talked about decentralized application development. Again, it's the idea of combining the smart contract backend with a front end that allows you to interact with applications. What are some problems? They're clunky to use, inefficient, and often security is a big problem. So who here's ever heard of a decentralized application platform being exploited? Or you might have seen it on the news, maybe some sort of exploit or attack on a cryptocurrency application. Anyone heard of any, maybe on the news, maybe if you look at any financial news like on Bloomberg or maybe just on the internet, you've heard of like some cryptocurrency application being exploited or hacked. Leo, Ray, you guys, maybe? You guys have ever heard of a application? Okay, well, it's not really. Okay, yeah. No worries. That's one of the biggest problems that we have is these these decentralized applications are often exploited for um, these decentralized applications are often exploited commonly. So you often have you often have DeFi applications or NFT platforms that, if they execute incorrectly, they're essentially exploited. And what that leads to is the unfortunate reality in which funds may be stolen, right? So if I'm interacting with some sort of contract, maybe again going back to the example of Curious Coin, I'm using Curious Coin to pay for some service, maybe to Ray or Leo, and we're both sort of using the smart contract as an exchange. Maybe an attacker accesses it and steals. Maybe I'm selling my car to Leo. They steal both the deed for the car and all of the funds. So that's one of the biggest exploits that occurs. That's one of the most common exploits that occur in DeFi platforms and decentralized applications. And so sort of moving on here. And so getting into why does this happen? The reason this happens is because the programming languages currently used on blockchain lack basic inbuilt testing features, and they're really hard to use. So this is what current programming on blockchain technology looks like. So does anyone sort of see the problem with this? If you guys can, yeah, just type in the chat. Does anyone sort of see the problem with this code? So this is in the language Solidity, which is what you use to create applications for the Ethereum blockchain and most other blockchains. A lot of blockchains use Solidity for the application. Does anyone see the problem? Does anyone think this is easy? That's the other. So say if you think this is easy to understand, please let me know in the chat, because you probably have a lot of jobs. Does anyone so obviously this is extremely difficult. Even if you're an experienced programmer, I mean, you guys are all in high school, this will be very difficult for you to sort of understand and go through. So, this is dealing with byte transformations. You have to understand, doing arithmetic or doing mathematics in different size bytes. And it's difficult for your average programmer to understand. And to sort of contrast it with PHP code. And if you ever look at some of the other presentations I always use these two slides because what we're doing with Atom Night is essentially trying to make it easier to build on blockchain technology by creating a new layer one platform. We're trying to integrate a more efficient blockchain with an easy to understand program language, essentially with the goal of allowing, talented students such as yourself to be able to actually program using program on blockchain technology. But again, one of the biggest problems you have with current tech is you can even make the argument that this PHP code, which is very old, especially for you guys, I was in high school 3 years ago, I graduated high school 3 years ago, or 2 years actually. So in 2020, so exactly 2 years ago, and I learned PHP, but I never used it. And most people, if you're a developer, you're going into college, you tend to use stuff like React, Python for your front end technologies, which you guys might have learned in some of the other workshops. So no one uses PHP because it's so complex. But you can even make the argument that this PHP code, which essentially it's doing the same thing, it's creating a marketplace as this. This is creating an NFT marketplace. This is creating a basic marketplace. You can argue that this PHP code is simpler and easier to use than your Solidity NFT code. So does that make sense? Does anyone have, before we leave 5 minutes for like final Q&A and discussion, does anyone have any questions on why building with smart contracts and decentralized applications is so difficult? Feel free to ask in the chat. Anyone have any sort of comments on why smart contract platforms are so difficult to use? Does anyone have, okay, well, if no one has any comments on that, we'll get into the open problems to sort of conclude the workshop. So the open problems are, first, the adoption of succinct blockchain protocols that actually use advanced cryptography to allow anyone with a device that possesses an internet connection to run a node. So we previously discussed about the storage problem, the fact that blockchains become so big that we have to rely on these other platforms to actually connect and send transactions, interact with applications. With the adoption of succinct blockchain protocols, we can actually create blockchains that allow anyone with a device like a mobile phone to actually run a node and actually interact with the blockchain. So now I don't have to rely on Infura or MetaMask to actually connect the blockchain, interact with applications, send transactions. One of the things we can do is we can rely on long-term security for proof of stake networks. So currently, proof of stake networks we talked about earlier, they don't have the same cryptographic protections as proof of works do. They don't have the same computing power dedicated to it. Thus, anyone with money, or maybe anyone who has the ability to prove to all the nodes that they have a lot of money, even if they don't actually, can overtake the network. So working on solutions for that. And finally, easier to use programming languages for smart contracts and more secure smart contracts, which is what we with Atom Knight Labs, what we're working on, is creating a more smart and easy to use programming language. So our biggest sort of focus is on creating a Pythonic programming language. Oh, yes, Ray, please go ahead. Yeah, Ray, type your question out. Type your question out. What gives cryptocurrency its value? Yeah, great question. The best question, the best answer to that is the market, right? So if there's demand, and this really applies to anything, it's just the market. So again, what if, for example, if we just decided to come up with Curious Coin, what would give? And there's different ways different cryptocurrencies handle this. There's more modern. There's and this is going to get deep into sort of economics. We only have 5 minutes left, so I'm not going to do that. But traditionally it's just demand. So when Bitcoin was created, it had no value. It was worth $0, and the reason Bitcoin's increased in value was because people started purchasing it from people who had first done some mining and gotten some coins. They started purchasing it and they started using it for services. And the more and more people use Bitcoin, the higher it got in price. Then people realized, oh look, this is actually something that's only, that lever, its supply will never be more than 21 million. It's actually a pretty good bet in terms of inflation, because as the amount of dollars in the economy grow and grow, Bitcoin's not going to grow the same rate. So the rate for one Bitcoin to $1 should naturally increase. Thus, a lot of big financial firms, hedge funds on Wall Street and the Canadian market, et cetera, like around the world, started purchasing Bitcoin to guard against inflation. And that led to the price, reaching the astronomical highs we saw in 2021. So that's why Bitcoin has a value. Other cryptocurrencies, you'll see a ton of them in the market. They get their value from something called an automated market maker, which is essentially this entity that manages to, at a 1-to-1 ratio, create some sort of relationship between the tokens and the typical currency. So does that sort of answer your question, Ray? Please reply in the chat if yes. Anyone? Right, does that answer your question? Okay, I'm assuming the silence means a yes, but if it did not, please follow up in the chat. But yeah, so like, oh, there. So basically, publish it, and as long as they use it. Yeah, I'm assuming what you're saying is, as long as it has usage, it has value. Yeah, that's a great point. Yeah, as long as there's usage and there's some sort of, the issuance is not crazy, and if you've seen the news of several major cryptocurrencies crashing, the underlying economics of them weren't sound. As long as you have a fundamentally sound cryptocurrency and you get mass adoption, you get a lot of people using it, yeah, it'll have value. I think it's the same for any product we have in society. Like, you can ask the same thing, like, why does the iPhone have value, or why does it have anything? It's because people want it, right? There's demand, and people are willing to pay a certain price for it. So that's sort of the same way cryptocurrencies have the value, and that people are willing to pay each. So rather than paying some sort of central entity for it, we're willing to pay each other for the price. So if Curious Coin ever becomes a thing and it has a price of like $2, it'll be because everyone in the Curious community has collectively decided through their economic decisions that this is a fair price for it. But yes, sort of getting into what we're doing with Atom Night is we're trying to make an easy to use blockchain development platform. We're trying to get more people who are not that experienced in blockchain, not that deep into Solidity and Web3, to build decentralized applications. One of the things we'll be actively doing once we have our proof of concept is going to high schools, going to colleges, and recruiting their developers to actively participate in anyone who's interested to actually test out the programming language and create applications. So if that's of interest to you, be on the lookout for that. I mean, obviously, I'm in touch with the Curious community, and I'll definitely reach out when that's a reality. But I think that pretty much concludes the workshop. Hope everyone had a great time. I'm going to go ahead and stop the recording.